Today we have a very special guest in our podcast. This is Alex. He is currently a senior biomedical engineer at Medtronic. He got his bachelor's in mechanical engineering, his PhD in biomedical engineering, both at Georgia Tech, and then he did postdoctoral work at Yale. And like I mentioned before, he's currently at Medtronic in the medical device industry. So, Alex, we're very happy to have you here. Again, thank you for taking time off your Saturday to be here. It really means a lot to us.
No, thank you. I'm happy to be here and take part. Thanks for putting all of this together and having me on.
Yeah, and I honestly, it's really good to have you here because we always get comments from people that are unsure if they should do BME as a bachelor's, but maybe just do some other kind of engineering as a bachelor's and then go into BME as a PhD or master's. So I think you're a perfect example of that. And so we'll just go ahead and talk about your career path. Why did you choose to study mechanical engineering in the first place?
Yeah, so mechanical engineering for me, when I started at Georgia Tech, I knew I was interested in engineering in general, and actually BME and ME were the two that I was kind of most interested in. And without having a lot of information going into the major, a lot of what you can do is just sort of look at the curriculum.
Hmm.
And I was very interested in physics. I was not particularly interested in chemistry, and there was a very big divide in terms of which one had a lot of physics and which one had a lot of chemistry. And so I kind of leaned towards mechanical engineering, and it worked out really well for me. A lot of people end up having to switch halfway through because they they didn't know what they didn't know. But for me, I got lucky, and I loved mechanical engineering from the moment I started till I graduated with my bachelor's degree. So
That's awesome. And so, what led you to deciding, I want to get a PhD and I want to do it in BME?
yeah, so you'll probably pick up as we're answering a lot of these questions that a lot of what happened to me in my life is sort of luck. So I took a class called Strength Materials, Mechanics of Materials, and my professor's name was Rudy Gleason, and he did research in biomechanics, and he told us a little bit about it at the beginning of that class. And so I actually didn't have an intention when I was doing my bachelor's of going into graduate school, but I thought what Dr. Gleason was doing was so interesting that I kind of asked him if I could work in his lab and just see what it was and what he was doing. And he was nice enough to let me, and it worked out really well. Again, I was lucky and fell into something that was really, really interesting. There were a lot of challenging problems that people were addressing. There were a lot of really smart and really nice people in his lab to work with. And after working with him as an undergrad for a year, he offered me a position in his lab as a PhD student. And so I took it with a lot of excitement. So grad school, the PhD and BME wasn't necessarily always the plan, but it worked out well because, as I said, I always had some interest in BME and kind of had to make a decision for my bachelor's. And the way that it worked out, I found out through my coursework that mechanical engineering can apply in many different ways to biology, and it was
Right.
a great way to get involved in that.
Could you maybe give some examples of how mechanical engineering can be applied to BME?
Sure, there are a lot of examples, and we could spend all day going through a lot of the different applications. So I would just tell you a little bit about what I did to apply my mechanical engineering background to BME, and the short answer is biomechanics.
Hmm.
So that class that I told you about was called Strength and Materials, which is understanding how different materials deform under certain loads. And in undergraduate courses, you focus on traditional engineering materials like wood, metal, plastic, things like that. And biomechanics for me is essentially the same thing, just applying those principles to biological tissue.
Mhm.
And that has a lot of relevance in a lot of disease contexts because what we know is that the cells in your body actually respond to mechanical loads. So the
Mhm.
materials, like in a blood vessel, it can bear the load of blood pressure, but the cells that are in the wall kind of sense that and they respond to it. And that's kind of a fundamental component for the ways that a lot of diseases develop. So really understanding, having a fundamental understanding of how mechanics apply in specific biological contexts is a key way, a key interest for me in how mechanical engineering can apply to biology. But there are, any of your standard mechanical engineering classes, fluid mechanics, heat transfer, thermodynamics, they all have a wide range of application
Mhm.
in BME contexts. And so there are many opportunities to take mechanical engineering and apply it to biology, I think. So
Yeah, I think it's very interesting, and that is very true because to treat diseases, we're used to taking drugs and like the chemical interactions, but when you look at the effect of mechanic mechanics in diseases, it's really where the source is coming from, I think most of the time. So it's definitely a very interesting area of research. So I have a question actually, like I kind of just came up with. I don't know, would you be able to compare how mechanical engineering differs from biomedical engineering, like in terms of like the degree itself? I know you did a PhD in BME, so it's kind of different from like comparing a bachelor's in BME from mechanical engineering bachelor's. But do you think there were any major differences that you were able to distinguish from the biomedical engineering degree from mechanical? I mean, other than all the medical applications, or if there's
sure,
not
yeah.
any, or
Uh, Um, I would say so. Not having a lot of visibility, I didn't do BME for undergrad, and so
Mm.
I'll be speaking a little bit out of turn probably, but I can give you my opinion. Um, I think the key the key difference is, in any undergraduate curriculum, you only have so much time to pack material into 4 years, right? And with BME, it's actually quite difficult because you're trying to learn many of the traditional engineering principles while also becoming an expert in the fields of medicine and biology. And so you're
Mm.
kind of having to double up a little bit on the material that you need to learn. Um, and so I think what ends up happening is to develop that expertise in the medical and biological fields, you end up taking your biology courses and your physiology courses and your anatomy courses, and the traditional engineering content like thermodynamics and strength of materials becomes applied specifically in the context of biology rather than covering the broad range of all the different engineering applications that you could look at. But that's tough to say because the content in the curriculum differs very significantly from institution to institution,
Yeah.
and so that's kind of painting with a very broad brush. Um, but I think um, yeah, that's the key difference for me is the added expertise that's needed in the medical world as opposed to focusing exclusively on traditional engineering applications. So does that answer your
Right.
question?
Yeah, no, definitely. And that is one of people's major concerns when it comes to biomedical engineering, actually, as a bachelor's, um, that how can you learn so many different topics in such little time? And usually ends up in BME degrees, really, or like BME majors, knowing a little bit of everything and not so much going in depth in one specific area of focus. So I think that's where a lot of people come in and say, well, I think I want to do mechanical engineering or electrical engineering and really strengthen these skills and knowledge and then apply it to the biomedical applications. So I mean, it's, it totally depends on, I think, your personal interest. And if you want to do that, I think it's great. But yeah, no, that was a great answer. And so moving on to your next step, which was the postdoc that you did at Yale. What inspired you to go to Yale and do a postdoc, and how did you get there?
So the postdoc was an effort in continuing to develop as a possible um, lifetime academic.
Mhm.
So I did have interest at the end of my PhD in looking for faculty positions at major research institutions, and I wasn't absolutely certain that that's what I wanted to do, but I knew that if I didn't take the postdoc, that it was going to be much harder to pursue that avenue later on down the road, and so I wanted to give it a shot. And I loved my time at Yale because just like Georgia Tech, there were lots of very nice and very intelligent and very just sharp people that were working there, and it was a really fun environment. I got connected with my postdoc advisor through my PhD advisor,
Mhm.
and it was kind of an organic connection. And my PhD advisor said, "Alex is looking for a position. Do you have any?" And Dr. Humphrey, who's in biomedical engineering at Yale, said, "Yeah, sure. Would be great to have him." And I was interested in working for Dr. Humphrey because he is also an expert in biomechanics, but he has a heavy emphasis in what he does in something called mechanobiology, which is that field that I told you about where we say cells sense and respond to their local mechanical environment. And he works with a lot of very interesting people at the medical school at Yale, and so where my PhD was very uh, heavily focused in the mathematics of
Mhm.
biomechanics. Working with Dr. Humphrey, I still got to do the mathematics, but had a little bit more exposure to the biological side of mechanobiology and biomechanics. So that's kind of what took me there, and I was there for 4 years before I finally made the decision to move out of academics and take the industry position that I have now.
Wow. So it sounds to me like, all these opportunities really came through the connections that you had first when you were an undergrad, then during your grad school. So it's really good to hear this, because I always tell people that one of the most important skills that you can develop during your education career or your educational career is networking. And I think that's very, very important. So were you part of any like clubs or organizations, or do you feel like most of your networking came from being part of these research groups?
That's a good question. So I was a part of various groups, both at Georgia Tech and at Yale, that were primarily aimed at serving the local. At Georgia Tech, it was serving the local graduate student community, and at
Mm-hmm.
Yale, it was focused on serving the postdoctoral community. Um, those I think those are very, very important, and I would not have traded my experience in those for anything. But those were not the primary drivers for me of networking. A lot of the
Hmm.
ways that I got connected with people weren't primarily through those opportunities. It came more from my work in the research labs. So as I mentioned, my PhD advisor is the one that connected me with my postdoc advisor, and that's how I made made that connection. So,
Hmm.
but the service opportunities are always really important because, as you said, networking is incredibly important. And the thing about networking is that you never really know where the networking will work out. So just because I
Yeah.
didn't have connections through my service opportunities doesn't mean that others won't. And I think that if you ask um, others that I interacted with in those service roles, many of them probably did make important professional connections through those opportunities. So.
Yeah, no, that's a great point, and I totally relate to you in the sense that I also made my connections mostly while I was doing research, and then that took me to my internship where I'm currently working at. So, yeah, but you can also hear of people finding those really good connections at organizations, and they can find them in their next job too. So it really doesn't matter where you go. It's just like, talk to people, like you never know who could land you your next opportunity. But yeah, that's great to hear. So I guess just going into the next step of your career, you decided to start in the medical device industry with Medtronic. How did that come along?
So again, a little bit of luck, which is always the key in what you're doing. But the academic route, I had a vision kind of what I wanted out of my job from a research perspective, and I always could see how an academic position would fill that vision for me.
Mhm.
And as I continued on in my postdoc, it kind of became clear that it that there were probably other ways of filling that vision that aren't exclusive to research professor opportunities. And so I did, I applied. I decided to apply for everything. I applied for faculty positions at research institutions. I applied for faculty positions at teaching institutions, and I applied to industry positions. And kind of said, I need to be a little bit open minded about what the next step is for me.
Mhm.
And this position at Medtronic that came up was one that was heavily focused on research in biomechanics and a little bit of machine learning, which is, I didn't mention that, but that's a little bit of what I did in my postdoc as well. So the description fit very nicely, and the only other opportunity that I had one other industry opportunity that was less research oriented, and I had a teaching opportunity, and I had to really make a decision about whether it was the research or the teaching that I was kind of focused on. And so when you're presented with a bunch of options, you have to make a decision, and I made a decision, and I'm very thankful for the one that I made because I could not have crafted a better position for myself than the one that I have at Medtronic right now. I I love the people that I work with. I love the work that I'm doing. I love the environment that I'm in, and I think that uh, it's that's a lesson that I learned, is that it's important to be open-minded and
Mhm.
flexible in the way that you approach your career, because had I continued kind of relentlessly pursuing that academic position, the research academic position, I could have missed out on something
Right.
that has turned out to be really, really great. So um,
Yeah, no, that's great. And so apart from that, that similarity in your skills in research and the position at Medtronic, like what else do you think helped you get that job? And I guess another question I would have is, did you like apply online? Was it through a connection that you got a job? How did it go exactly?
so I did apply online, but I also had so a friend of mine in my lab at Yale, his wife had previously applied to a position at Medtronic in the same group, and ended up taking a different job. And so when Medtronic had this job open, they emailed her and said, "Hey, are you still interested? If not, do you know anybody?" And she
Mm.
kind of brought me in and said, "I'm not interested, but here's Alex, and I think he already applied for the position, so you guys should talk." And it went on from there.
Wow,
So again, the personal connection was tremendously helpful, and that was just kind of luck that my friend's wife had applied for this position in the same group, and that's not to say that it couldn't have happened without the connection, but it never
right.
hurts to
Yeah,
have the connections.
yeah, I agree. I mean, again, like that's the importance of having connections, and the more you have, like you just never know who could be the next one. So right now in the medical device industry, what skills, either technical or like soft skills, do you feel like you use the most in your day-to-day job?
So, from a technical skill perspective, for me personally, that's a pretty important component because the role that I was hired into was very specifically meant to be a technical position.
Hmm.
So all of the work that I did in my PhD and all of the work I did in my postdoc, I'm leveraging for what I'm doing on a day-to-day basis. So the mathematics of biomechanics
Hmm.
is something that I'm using um, basically every day. So I use a lot of MATLAB. For all of you out there who curse the name of MATLAB, it's turned out to be quite helpful for me, and I cursed it too when I used it the first time. So I'm with you, but I use a lot of MATLAB. We use a lot of Excel. Technical communication skills are really important. So how to write a written document that clearly explains the work that you're doing, not only to the technical community but to the non-technical community as well, because there's a lot of cross-functional communication that has to happen for the individual and for the organization to be successful. And so I do a fair amount of presentations as well. So again, from a technical communication perspective, being
Hmm.
able to put down thoughts cohesively onto a slide deck and present it out to people in a way that's digestible is something that uh, I'm still working on. Honestly, it's something that my PhD advisor and my postdoc advisor were masterful in doing that, and I learned a lot from them and just watching them do it the way that
Yeah.
they do it. But that's something that I'll continue to have to improve every day, as well as the technical skills as well. So.
Yeah, no, that's great. And I just like to take a few seconds to just thank everyone for watching. I know we have a lot of comments here, so it's good to see the excitement, listening about Alex's career. So, sorry, I lost my train of thought, but I had a question. I'll just jump into the next one. Um, so what does your day look like now during a global pandemic compared to maybe what it looks like before? Do you feel like there's major changes, or yeah, how's it going for you now?
So for me personally, I have been about as minimally impacted by COVID as you possibly could. So the benefit of doing the mathematics of biomechanics is that you need MATLAB and your computer, and you need a sheet of paper and a pencil to work
Mhm.
out the numbers. um, so I can do a lot of what I do at home, and my day to day involves a lot of kind of a lot of data analysis. And so I can do that anywhere. Writing reports, I can pretty much do anywhere. Developing presentations, I can do anywhere. And now with um, Zoom, I can deliver the presentation from anywhere.
Right.
Um, but So my day-to-day hasn't changed that much, except I don't have to commute, which is nice.
Which is great.
Yeah, but there is obviously some limitation in terms of, to do data analysis, you have to be able to collect data, and to be able to collect data, you have to be in the lab. And I'm fortunate that, we have a testing services department that is really great and can be in the lab collecting the data on my behalf. But there are some certain scenarios where I would otherwise be in the lab and I'm not necessarily able to do that. So that's the primary thing that's sort of missing a little bit. But I've been really thankful that I've been able to maintain productivity, and appreciative of my company for being so flexible in the way that they have handled it. So
Yeah, no, that's great. And I know Medtronic was one of the companies that actually kept interns during this virtual transition. So that's definitely great to have a company be able to accommodate to the needs. So I remember the question that I was going to ask before, which is, now that you're in the industry, um, do you see advantages? And I'm sure you will, but what are the advantages that you see you get from having a PhD rather than maybe someone who has just a bachelor's or a master's? Have you seen any like very obvious advantages that you have because you've done um, just more education?
so the advantage is that I was, I think, pretty uniquely qualified for the role that they were looking for.
Right.
Had I not done it, even having done my PhD, I don't think I would, without doing the postdoc, I don't think I would have been as qualified for that position as I was having done the PhD and the postdoc.
Hmm.
So if you're interested in heavily technical roles, there I think are plenty of opportunities to hire on in an industry setting with a PhD in a way that you can actually leverage the skills that you get from the time that you spent getting your PhD.
Hmm.
But that being said, I think one of the primary objectives of getting a PhD is just learning how to learn. And again, being around a lot of people who were really sharp helped me develop that skill, because that can be really hard to do.
Yeah.
So there are a lot of there are a lot of benefits and a lot of ways that industry can leverage PhDs. But that being said, I think that I don't necessarily see people without PhDs being disadvantaged in technical roles
Mhm.
because they didn't go to do the PhD. It's a very, very individual and kind of case by case scenario where you have to make the most of your the opportunity that you have,
Right.
and not having a PhD shouldn't necessarily be a stumbling block unless there's just a very specific type of work that you want to be able to do, and then the PhD has its obvious advantages. So
Yeah. No, that's great advice. And I totally agree with that. So I think the next question would be, throughout your educational and professional career, what have been the major challenges that you've seen, and or when you've had these challenges or obstacles, what kept you pushing forward?
that is a good question. So with the PhD, the major challenge is for me was
Mhm.
kind of getting thrown into an environment that was really unfamiliar for me. So
Mhm.
we talked about mechanical engineering versus BME. Um, and since I did mechanical engineering and then came into a BME program, I knew basically nothing about biology. And I had all these people talking about biology to me, and I didn't know what they were saying. And so there was a really, really steep learning curve there. And in the process of developing a research plan, which is something that you have to put forward to go through your PhD, there was a lot that I didn't know, and I had a committee who I think was very interested in my development, and they rightly were pretty critical of my initial proposal, which never really feels very good.
Nice.
But I think being able to take that criticism and turn it into something good is, again, something that you really have to be intentional about. And understanding that my committee was looking out for me and was trying to do something that would be helpful for me. The guidance that they gave me, I think, turned out to be tremendously helpful, and again helped me learn how to learn. That's what they were there to help me do. So that was one challenge from a kind of technical perspective. The job search, I'm sure everybody is familiar, just from a personal perspective, what a challenge the job search can be. And I was looking for jobs for a couple of years, actually, before I found the one that I have now at Medtronic. And I think just I don't have any great words of wisdom in that, except just for perseverance and understanding that something is out there. And I think I mentioned this earlier, but being flexible and kind of open-minded about what jobs might be able to fill the vision that you have for your professional career is something that's really important, because there is a lot that's out there, and there are many good opportunities. So I guess, yeah, that would be kind of the summary of my challenges and what I learned through those. So
Yeah, no, that's great. And yeah, I totally agree with perseverance and what you said about flexibility. I think is very important. And yeah, it's interesting because I always tell people that I feel like no matter what engineering degree you choose, the core of it is learning how to solve problems and think critically. So it's just also very interesting because I haven't gone through the PhD path, and I doubt I ever will, but it's just good to hear from someone who has and know, what is that core that you get from your PhD, which you've mentioned that it's learning how to learn. And it may sound silly, but it is very important to really learn how to learn. So that's awesome, and I'm glad you mentioned that. Um, so I think it's time now to maybe put up some questions that we've gotten from the viewers. And I know I've seen several. So do you want to put the first one? Okay. So, okay. How important is software knowledge in biomedical companies?
um, in a word, very. But when you're asking at an organizational level, I think the answer is that it's very important. And I think probably the spirit of the question is, how important is it that each individual have a great degree of knowledge in any given software? And I would say, again, that's very context dependent. So there are many people who use kind of Microsoft Word and Microsoft Excel and PowerPoint, and that's the majority of what they do in their day, because that's what their job demands of them. If you want to take on a software engineering role, obviously you would need to have a great degree of expertise in a number of different platforms. I use MATLAB kind of as my exclusive software platform, which there are many other people who know many other software applications and languages than I do, and it fits them for what they do in their day to day. But again, if you're interested in a technical role, it's just helpful to know, kind of think through, what is it that you want to do on your day to day. If you really like being the one to code software, or even if you just like being around that, then developing some expertise in those platforms would be a good thing. But certainly there are many opportunities across biomedical companies that don't require a great deal of expertise in many different sophisticated software platforms. So
Yeah, no, I totally agree with that. And I think it's very important. And it can be kind of hard, but I think one good way of knowing what skills or technical skills you should develop is maybe search for jobs out there that you're interested in, that you would envision yourself having, and then see those requirements, because it really depends. Like, not everyone is going to know programming, not everyone knows SolidWorks. So at the end of the day, it's really up to, like, what do you see yourself doing? What skills do I want to have that then I'm going to bring into the company? So I think that was a great answer. Okay, so the next question would be, I'm doing biomedical engineering, so my question is that after BME, what should be a better field to do masters? Um, in my opinion, I think it's very dependent on what you want to do. What would you say, Alex?
I would totally agree with that.
Yeah.
So speaking from my personal background in mechanical engineering, we talked about how BME is kind of you learn you have to learn a lot of different things, and it's funny to hear that, because in mechanical engineering we would always joke to ourselves about how we're the jack of all trades in traditional engineering fields. So the electrical engineers are better than us at electrical engineering, and the chemical
Right.
engineers are better than us at chemical engineering. But we know some about all of it.
Yeah.
So if you're unsure about what you want to do next, and you know that you don't want to do BME for a master's or for a PhD, personally speaking, I think mechanical engineering is a great way to go. But yeah, obviously it's very dependent on what your specific interests are. So
hmm Yeah, no, I agree. Um, okay, next question. In my country, the work limited to maintenance of medical devices. Oh, okay. So yeah, I think there's a branch of BME that specifically goes into more of the maintenance of medical devices and not so much the design, right? Um, how can I develop myself? I think the best way is to get internship experience. I don't really know much about that field of working as uh, like in the hospital, I guess, doing maintenance on devices. But do you have any knowledge of that, Alex?
my knowledge of that is pretty limited.
Mhm.
My thoughts around that would be, so if you're maintaining devices, likely what your goal is to identify ways that the devices are starting to wear down or fail and prevent them from doing those things. And so if you're interested in kind of parlaying into a design role, and you want to develop yourself in that respect, um, my advice would be to do some research in comparing the different kinds of products that exist within a different category or within a specific category, and
Mhm.
understand what's better about this product versus what's better about that product. And you can kind of start to think like a design engineer and think to yourself, well, if this company had done it this way, then maybe we could eliminate a certain level of maintenance that's required for this, and it would save X number of dollars for the company or for the
Mhm.
user. So kind of that's, I think, kind of an organic way you can try to start thinking like a design engineer, in the process of having to maintain the products that
Right.
ultimately fail, that were designed by the original design engineers. So I don't know if that's good advice or not. That's just the first thing that came to my head. So
Yeah.
so hopefully I'm not leading the wrong
No,
path.
that's great. That's great advice, in my opinion. But I also do have very limited knowledge of that. So we are running a little bit out of time. So we're just going to answer one more question, which is, can you share your PhD research experience?
Sure. So I mentioned earlier that a lot of what I did was focused on the mathematics of biomechanics and understanding how different biological tissues respond to loads, but more importantly, how they adapt to them to either maintain homeostasis or if they don't do it correctly, how does that promote disease? And I looked at a couple different things actually. Primarily, what I looked at was everything was in the vasculature, but I looked at some in the lymphatic vasculature, and so I have some research papers that are devoted toward understanding the onset of lymphedema and how biomechanics might play a role in that. And I have kind of an experimental paper, and I have a computational or a mathematical paper that goes along with that. But I also had an opportunity to do some more clinical research in Ethiopia, actually,
Mm.
in understanding how biomechanics might play a role in the development of cardiovascular disease, specifically in the context of HIV infection and treatment. So, patients who are infected with HIV and who are being treated for it are developing cardiovascular disease earlier and more frequently, and trying to understand how biomechanics might play a role in that. And so we were in a hospital in Ethiopia, taking blood samples, doing ultrasound imaging to look at how blood vessels behave under in vivo blood pressures.
Mm.
So that was kind of an additional component of my research, and all of it was really interesting and enjoyed it a lot, but all under the heading of biomechanics. So
Yeah, no, that's awesome. It's really good to hear because I as a BME bachelor's, I always wonder what does biomechanics really entail because I just took like one biomechanics class and then the rest were mostly on like cell and tissue engineering. So it's definitely very interested to learn about that. And okay, so I think we've reached the end of this podcast. So just to close up, I know you've shared a lot of great advice, but do you have any final summary of the advice that you would give either students pursuing BME or engineers that want to go into the biomed industry, or maybe young professionals? Yeah, just any final advice you would have.
I think my advice would be along the lines of what we've talked about a lot during this podcast, which is just identify what you like to do and develop a plan around it, and then hold that plan with open hands and understanding that the plan might change, and that's okay too.
Mhm.
And I think having a plan that that you can allow to change is the best way to have satisfaction in whatever circumstances you might find yourself in.
Mhm.
So yeah, understanding what you like and how to get there is I think an important component. But yeah, I think I'm sure that everybody listening to this podcast is everybody's very ambitious. Everybody's pursuing engineering and probably moving down the right path. So I applaud all of you for taking the time to look into different ways to approach your careers. And obviously, thanks to Mary for putting on the podcast and providing the opportunity.
Yeah, no, thank you. That was great advice. And, our purpose is always to encourage people out there because you can look up, what is engineering and you can find a dictionary definition. But I think really listening to people and their personal experience is great because there's so many things you can do with it. And, maybe someone today listening is really interested now in biomechanics. And so we've accomplished our goal. So thank you so much for being here, Alex, and we really appreciate your time. And I guess it's now time to say bye to the viewers. So thank you all for joining us, and we will see you next time. Bye.